Hello everyone, hope you're doing well. In our previous video, we explored the clean architecture and the historical evolution of a software architecture. We walked through concepts like hexagonal architecture, layered architecture, onion architecture, and clean architecture itself. For instance, we noted that the notification interface is part of the application layer, while its actual implementation exists within the infrastructure layer. In the application layer, we defined contracts known as ports, and in the infrastructure layer, we have concrete implementations referred to as adapters. This structure is why we refer to this architecture as the port and adapter architecture. In this video, we are going to deep dive into the clean architecture, exploring its layers, principles, and how it's implemented in a real-world .NET application. All the source code is available in my GitHub repository, which you can download and explore. Now let's jump right in. As we discussed earlier, software architecture has evolved to improve maintainability, scalability, and testability. Clean architecture, introduced by Uncle Bob, Robert C. Martin, focuses on keeping the business logic at the core while isolating external concerns like databases, frameworks, and UI. In clean architecture, we have four major layers. Domain layer that holds the core business logic and it has no dependency on anything. Application layer, we have business rules, CQRS, and interfaces here. Infrastructure layer, we have the database persistence, external services, concrete implementation, etc. Presentation layer. This holds API, UI, controllers, and dependency injection setup. All took place here at this layer. The main principle behind clean architecture is dependency inversion, ensuring that the inner layers do not depend on external details like databases or APIs, making the system flexible and testable. For example, the application layer does not have any dependencies on the infrastructure layer. It solely contains the interface that are implemented in the infrastructure layer. This means that the application layer is testable as it operates independently of the infrastructure layer. Now let's explore how these layers are structured and implemented in our .NET solution. At the center of our application is the domain layer. This is the heart of our application. In our Visual Studio project, we have a clean architecture domain project containing entities like book, person, etc. This defines the core data structures used throughout the system. Base entities and base auditable entity shared properties like ID, created date, and updated date are here. Value objects like genre, address, etc. All immutable objects are here. Domain exceptions like unsupported genre exception, etc. All custom exceptions throughout the domain level are all here. One important point about created datetime in the base auditable entity is that we use datetime offset instead of datetime to store the creation and update timestamps because it includes the offset from UTC, which provide more context about the specific points in time, including the time zone information. This is particularly useful in distributed systems where the application might be used across different time zones. Using a datetime offset helps avoid ambiguity and ensures that the exact point in time is preserved, regardless of the local time zone of the server or client. Since the domain layer is completely independent, it does not reference any other layers. It only contains pure business logic. If we take a look at the clean architecture illustration, as you can see, there is no dependency for this layer and it's completely independent. The application layer sits on the top of domain layer and defines business use cases. encapsulated in services and handlers. We have implemented handlers in the entities and books, commands, create, and other places, as you can see here. Interfaces for external services like email service, etc. And CQRS, command query responsibility segregation. We separate read or queries and write or commands operations. Our application follows the CQRS pattern, meaning if we have a request, this request is either a query or command. If we have commands like create book command, delete book command to modify data, create, update, or delete, and queries like get book query, only retrieve data. It is something like this. When a request is a query, it simply retrieves data from the database. In contrast, when a request is a command, it can create, update, or delete data in databases. We may have one or more databases that are synchronized with each other. Each command or query has a request model. For instance, create book command handler that processes the request, and optional validation rules like title length constraints, etc. In this architecture, an application layer only contains interfaces, ensuring there is no dependency on infrastructure details. For example, the email service interface defines an email sending contract. The actual email implementation is placed in the infrastructure layer, following the dependency inversion principle. Another important concept here is the unit of work pattern. We use unit of work interface to ensure that multiple database operations commit atomically. Either everything is saved or nothing is. That's why we have application unit of work interface here, and it inherits from the unit of work. If we take a look at the clean architecture illustration again, as you can see, application has only a dependency on the domain layer and nothing else. That's why we have this dependency in our application. The infrastructure layer contains concrete implementation of the interfaces defined in the application layer. In this project, I have created two separate projects for the infrastructure layer. However, they are essentially the same. I chose to separate them in this way to better manage concerns. Alternatively, you could combine them into a single infrastructure project. This includes Entity Framework Core configuration, our database ORM setup, application DB context, the actual database context used by Entity Framework Core, unit of work implementation, managing transactions for consistency, logging and handling system-wide errors, email service implementation, actual logic for sending emails. The key points are our application DB context is injected using .NET dependency injection. Instead of throwing exceptions, we return structured result objects to ensure better error handling. In clean architecture, the infrastructure layer depends on the application layer, but not the other way around. That's why if you check references for these two infrastructure projects, you can see references to the application project and domain project. And this is exactly what is required in the clean architecture, and you can see it here in this illustration. The presentation layer is the entry point of our application, handling API controllers, exposing endpoints for books, persons, etc. Dependency injection setup, registering services and middleware, global exception handling, ensuring errors are formatted properly. If we take a look at the illustration again, we can see that requests can originate from various sources, such as an HTTP request or a command line interface CLI command. Our controller receives these requests and then forwards them to a command or query bot, which knows the appropriate handlers for those commands and queries. After processing the request, we send back the appropriate response. In our API endpoints, we accept incoming requests, forward them to CQRS command query handlers, return the appropriate response. For example, in the book endpoint, the create book receive a create book command, which is passed to the create_book command handler, where it's processed and persisted. In program.cs, we register all dependencies: builder.services.add application services, add infrastructure service, add presentation services. This ensures that all layers are properly wired together. If we take a look at the clean architecture illustration, we can see that all dependency injections must occur within the presentation layer, and the presentation layer has dependency on all the layers beneath it. This is why we have registered everything here in the program.cs file. Now let's run the application and see how it behaves in Swagger. By creating a new book, we send a create_book command and we get a success response with the book's ID. To see handling validation errors, if we send invalid data, the global exception handler returns a well-formatted validation error message. And for fetching data using getBook_by_ID query, we retrieve the stored book. Everything works seamlessly thanks to the clean architecture structure. That's a complete walkthrough of a clean architecture in .NET. In this demo, we saw separation of concerns makes code modular and easier to maintain. Dependency inversion ensures flexibility when swapping technology. CQRS keeps read and write operations separated, improving scalability. Unit of work and result patterns improve database consistency and error handling. If you found this video helpful, like this video to support the channel and use the code in your own projects. Subscribe for more .NET and architecture videos. Also, feel free to leave a comment if you have any questions. I'd love to hear from you. Thanks for watching, and I'll see you in the next one.